Hello everyone, today I will be showing you my motion controlled mouse glove project, which I have named Glove++. Unlike some of my previous projects, the electronics and code are not that complicated, but the result is quite cool. What inspired me to make this project is my fascination with alternative ways of controlling electronics. Products such as the Wii, Xbox Kinect, and in more recent years VR controllers played a big part in my interest in this area. Thus, making something similar has been my to-do list ever since I started working with computers and electronics. This video will be split into three parts: the hardware, the algorithm, and the quick code overview. As previously stated, the circuit diagram is quite simple. The two most important parts are the ESP32 and the MPU 6050 module. The ESP32 was chosen not only for its fast processing speed, but because it has Bluetooth Low Energy and touch sensor support out of the box, both very important for the making of this project. All the other electronics are for power delivery. The power supply consists of a generic lithium-ion battery, a WAV-GAT battery charger module, and an MCP1826 voltage regulator. We also have input and output filtering capacitors and a switch. On the logic side, we have an ESP32 connected with the MPU through I2C, the three touch sensors, and a 3-pin header for setting of movement style. The algorithm. The algorithm consists of 5 steps. Step 1 is getting the raw data from the MPU 6050 in the form of a quaternion. Next, we convert the data into yaw, pitch, and roll. At this point, we know the orientation of the hand relative to the starting position. Then, we draw a line from the tip of the hand to an imaginary surface. The point at which the line and the surface intersect is essentially the mouse position, and the distance from the hand to the surface is the sensitivity of the mouse. This whole step is done because if we simply map the yaw and pitch to the x and y position of the mouse, a problem occurs. To demonstrate the problem, imagine we are moving the hand up and down, resulting in an up and down movement of the mouse. Now, we turn the hand 90 degrees in the roll axis and start moving the hand left and right. We would expect this to result in a left and right movement, but instead, we again get the up and down movement. With this problem solved, the last step is to apply some light filtering and averaging, and finally send the data to the receiver. Now it's time to look at the code. I won't explain in detail what happens in the code, only mention what I believe is the most important parts. One of the biggest problems going into this project were the so-called HID descriptors. These are arrays of 1-byte values that essentially tell the receiving device what data we are sending. HID mouse movement libraries already exist, but they don't work like how I needed them to. Most of them work by sending the speed and direction that the mouse is moving, while I needed to send the absolute position of the cursor. This was done with these values in the HID descriptor. However, the relative mouse movement style wasn't bad, so I decided to keep it in the final project. Choosing between the two is done with the header, which I mentioned in the hardware section. The other important part of the code is the getDisplacement function, which is essentially the implementation of the aforementioned algorithm. And that's pretty much it. I hope you've enjoyed this video. Any questions and suggestions are appreciated, and make sure to subscribe for any future projects. Thank you and bye.